All right, so this is a great example dealing with resistance and current and voltage, all right? So we're going to go ahead. You've got a battery over here on the left-hand side. We have 4 resistors, A, B, C, and D, and then we have a switch here that's open. Now, the first question is, how does the resistance of the circuit change when switch S is closed? So we're looking at the resistance of the circuit. Now, before it's closed, the current should go from the positive, it goes through the A, it doesn't go through B, then it splits and goes through C and D, and then it comes back together and goes back to the battery. And so when we add in that B, so when we close that circuit right there, then after the current goes through A, it now goes through B, C, or D. So essentially we've added in another resistor in parallel. Now, one of the things that we learned earlier is that as we add a resistor in parallel, that the total resistance of the circuit goes down. And so the answer to letter A should be that the total resistance of the circuit goes down as S closes. Now, of course, if you want to think about it in another way, remember that as the current went through, before, all of the current was being crammed through C and D, right? So now if you give it another place to pass through B, then the current now will have 3 choices of where to go, and so there's going to be less total resistance because there's going to be less current flowing through each one individually. All right, so that kind of leads to what we just said, that the total resistance should be going down. Now, letter B says, well, how should the current in the circuit change? Well, we know that V equals IR, or that I is equal to delta V over R. Now, if that's the case, we know that the potential difference is staying the same, right? That is being provided by the battery. That is not changing. Now, we just said that the resistance is going down. So if the top stays the same and the resistance of the circuit decreases, then the total current of the circuit should increase. Now, letter C then asks, how does the current through each resistor change? All right. Now, this is a slightly different question. This one's a little bit harder, I think, because now we have to look at each resistor. So we're going to look at A, we're going to look at B, we're going to look at C, and we're going to look at D. So we are looking at the current for each of those. Now, the total current in the circuit went up. Now, all of the current has to go through resistor A. So if all of the current is going through resistor A, then that means that the amount of current going through A increases. All right. Now, B as well, there wasn't any current going through B before, and now there will be current going through B, so the amount of current going through B increases. So now we have to decide on C and D. Now, the easiest way I can think of this is, well, we did just say that the current in A increases, and we know that current equals potential difference over resistance. So if your current just increased, and we know that the resistance of A doesn't change. Remember, resistance is a property of that resistor under these specific conditions. So if I went up and R stayed the same, then the result must be that V went up. Because if R is not changing, the only way that the current can go up is if the potential difference goes up, which means that whatever potential difference we had across this guy right now, well, more of it is going to be lost over A. So if I lose more potential difference there, then that means there's going to be less potential difference going across C and D than there was before. Less potential difference for the same resistance means actually less current going through C and D, which in a way should make sense because whatever was going through A before used to only be split between C and D. But now it's going to be split between B, C, and D. Some of the current is going to go through B that it didn't have to before. All right, so that's letter C. Let's move on to letter D. How does the voltage across each resistor change when S is closed? Well, we just talked about letter A there, right? We just said that the potential difference across A is going to increase, right? There's more current going through that same resistance, so its potential difference has to increase. If you think about about C and D, those are the next easiest ones. We just said that their current decreases. So if their current decreases for the same resistance, then that means that their potential difference is going to decrease. And then lastly, we need to look at B. Now remember, there was no current going through B initially when the switch was open. So if there was no current going through there, there would be no potential difference. The fact that now there's current flowing through there, well, that just means that the potential difference across B is greater than what it was before. All right. Now, the last question is, what happens to the power output of the circuit when the switch is closed? So this isn't too bad because we have learned that the power is equal to the current times the voltage. Now, the potential difference in our circuit, the total, is still the same, right? We talked about that before, is that the potential difference doesn't change because the battery stays the same. Potential difference of individual components will change, but of the circuit, there's only a certain amount being provided by that battery, so that stays the same. And then we just said that the current in letter B, we said that the current of the whole system is going to increase. And so if the current goes up, the potential stays the same. That must mean that the total power required in the circuit will then increase when we close that circuit. All right, so that is the end of this example. I hope that was helpful. A lot of great concepts here, a lot of good things to think about when we're thinking about circuits. If you'd like some more, go ahead and check out some more examples later.